Hello everyone, welcome to series lectures of Basic Electronics. Today we are going to discuss about P-channel E-MOSFET. There is a slight difference between the previous lecture and today's lecture. Here we are going to discuss about P-channel and previously we are discussed about N-channel. So let's see about P-channel. So first starting with MOSFET, metal oxide semiconductor field effect transistor is known as MOSFET. Here we are going to discuss about E-MOSFET, so enhancement MOSFET. Previously we discussed about depletion type, which is also known as off device, and normally it is closed switch. And we are going to discuss about here enhancement MOSFET or enhancement type, which is normally open switch, or we can say it is device on. So this is the difference between the depletion type and enhancement type. So in this lecture we are going to discuss about P-channel E-MOSFET. So here these are the symbol as we discussed in our previous lecture, that the difference between the N-channel and P-channel is arrows. Here we can see if arrows goes inside is known as N-channel. If arrow come outside it is known as P-channel E-MOSFET. So in this construction we are going to use this symbol, arrows is come outside. So these are the symbol, and terminals also remain same, drain, source and gate terminal along with body, or we can say substrate terminal. Basically there are 4 terminals are connected. MOSFET body is usually connected to the source terminal. So substrate and source is shown connected in together. We can see here in symbol, or also we can see it in construction. Now let us discuss about its construction. Here we can see in place of N we put it here P region, because it is P-channel E-MOSFET. So we can see P type region is here, and that large area is known as N type region. So due to this P type there is a flow of current, that's why it is known as P-channel E-MOSFET. So here we can see gate terminal is insulated from the channel. But remember this thing, there is no channel present between the two P type region. So this is the difference between the E-MOSFET and D-MOSFET. We can see in previous lecture in D-MOSFET that the channel is present in between drain and source, but here channel is absent. So this is the difference. Now in this topic we are going to discuss about 3 cases. Case number 1, we applied VGS is equal to 0. That means we shorted gate to source terminal, that becomes VGS is equal to 0. And noted at that time what happened with ID. That means your output current, which is known as drain current. Here we can see this is the biasing of E-MOSFET. So biasing should be at 3 terminals. That's why we provide here 2 different types of batteries. One is known as VDS and one is at VGS. VGS, that means it is gate to source voltage, and VDS, that means it is drain to source voltage. So here we can see P-type material is at drain and source terminal. That's why we have to connect here negative polarity first, because we have to attract here number of holes which are minority carrier charges in N-type substrate. That's why we can create one channel in between the P-type region of drain and P-type region at source. So this is the case number 2. In case number 3, we increase only VDS with constant of VGS. And now what happened with ID. So these are his 3 cases we are going to conclude, and after these cases we are plotting characteristics which is known as output characteristics, and from output characteristics we can plot transfer characteristics. So here we can see gate terminal is insulated from the channel. Now let us discuss and let us start with case number 1, VGS is equal to 0. Here we can see if your VGS is equal to 0, that means no voltage at the input terminal. Due to no voltage, there is no flow of current, that means your IG is equal to 0. That means IC is equal to 0, there is no field is generated at gate terminal. So there is no majority carrier or minority carrier charges attracted towards this side, this gate side. So that's why the flow of drain current is equal to 0, because we can see there is an absence of channel at case number 1. So VGS is equal to 0, that means your drain current, your output current is also 0. Now let us discuss about case number 2. If we apply VGS is in negative side. So what happens if we apply VGS in negative more and more? If we apply VGS in negative, due to negative terminal, number of minority carrier charges present in N-type substrate is attracted towards this terminal. So which are the minority carrier charges in N-type substrate? Obviously that are holes. So number of holes are attracted towards negative polarity. So due to this, if we increase more and more negative voltage, so more and more number of holes attracted towards this gate side, and due to this we can see there is a generation of channel. So in between drain and source there is a channel is present due to increase of this VGS in negative side. So due to this channel is present, if this channel is induced, which connects the P-type dot, and that's why it is known as threshold voltage, VTH. So drain current is flow from source to drain side. That's why we can see ID is equal to IS is equal to IDSS. IDSS, that means drain to source saturation current. So this is the case number. Now discuss about case number 3. If we constant VGS and we increase only VDS. If we increase VDS only, that means pinching off is started. If pinching off started, that means saturation is created. Then and then your channel is going to be decreased. So this is the case number. Now here we can see this is the characteristics of P-channel E-MOSFET. Here we can see on x-axis we have plotted voltages is VDS, and at y-axis we plotted ID. And from this characteristics we can plot easily transfer characteristics. So let us start with case number 1. In case number 1, we have seen that if your VGS is equal to 0, that means there is no flow of drain current. So VGS is equal to 0, no flow of drain current, that means it is nearly, or we can say close to the x-axis. After that, if we increase more and more negative voltages, that means VGS is equal to -1, -2, -3, -4 and so on. So your ID is going to be increased. Here we can see VGS is equal to -1, -2, -3, -4, -5 and -6. According to this, we can plot value of ID. So this is the drain current, or we can say drain characteristics of P-channel E-MOSFET. And from this characteristics, we can plot a transfer characteristics. So remember this thing, at transfer characteristics, we have to plot the G axis and ID at the Y. So if first condition, we can see here at VGS is equal to 0, at this time your ID is also 0, so it is plotted. Gradually, if we increase VGS value, here we can see, gradually we can see that ID's value is going to be. So this is the characteristics, this is drain characteristics, and that we can say it is transfer characteristics of P-channel E-MOSFET. So that's all for today's lecture. If you have any query related to this topic, you can mail me on this email address. Till then, keep reading, keep learning. See you soon in the next coming lecture. Thank you.